Trustable scans an AI agent's code, then compiles that one scan into a set of artifacts. Each one is a different lens on the same agent. Some describe what it may do, some enforce it at runtime, some prove it to an auditor. Here is each one and why it matters. First, the scan itself. It reads your agent's code and inventories every tool, agent, subagent, skill, and MCP server, then checks them against its rules. Most agent failures are not exotic exploits. They are misconfigurations right in the definition, an overbroad tool, a missing guardrail, a tool that shells out. The scan catches them before the agent ships as findings and a readiness score, each finding pinned to the exact file and line in your code. It outputs JSON or the static analysis results interchange format, SARIF, to gate CI. And every scan carries a deterministic ID that folds in the exact rule pack version, so it is honest about what produced it. Everything else compiles from one place, the contract. Trustable distills the scan into one canonical contract per agent, the tools it may call, with the dangerous ones flagged, like run diagnostics, which shells out, its handoffs, and its input and output guardrails. This is the source of truth. The manifest, the policy, the conformance spec, the sandbox policy, every artifact after this is rendered from the contract. The agent's intended behavior, written down once, in one place. The contract, made human-readable, the conformance spec. It states the expected behavior plainly, the allowed tools, the allowed handoff, the required guardrails, which tools need approval, and whether it can be enforced. Because this agent was fully declared, enforce is true. It is the shape a runtime checks live activity against, the exact thing a live monitor uses to allow the calls that fit the contract and deny the ones that do not. An agent's allowed tool list is, exactly, an authorization policy. So Trustable compiles it into policy as code. Open Policy Agent is a CNCF-graduated engine that already answers, may this action run? It is how Kubernetes does admission control. Trustable compiles the contract into a deny-by-default Rego bundle with no handwritten rules. At runtime, the host asks OPA about a tool call. OPA returns the decision, and the host enforces it. A tool that is not on the contract is denied. An empty allow list warns, instead of blocking everything. The same contract as a portable runtime governance manifest, Microsoft's Agent Control Specification. ACS is Microsoft's open spec for governing an agent at runtime. Instead of guardrails scattered across prompts and code, one portable manifest is evaluated at 8 lifecycle checkpoints across the agent's run, like before a tool call and before output. Trustable emits that manifest from the contract, the intervention points and the policies, written in Rego or Cedar, that an ACS runtime enforces, returning allow, warn, deny, escalate, or transform. Detection audits an agent before it runs. This one enforces while it runs. OpenShell is an NVIDIA project that runs an agent inside a kernel-isolated sandbox, denied by default network egress, file system, and syscall isolation, and crucially, the policy lives outside the agent, so a compromised agent cannot rewrite its own guardrails. Its policy controls the file system, the network, and the process. Trustable generates a least privilege policy toward that model from the contract, so the tools you allowed become an enforced sandbox. Findings only matter if the rest of the business understands them. So Trustable maps them 2 ways. First, to a recognized threat name, OWASP calls an overpowered agent excessive agency. Then to the controls your auditors already use, across 9 frameworks, NIST, ISO 27002, SOC2, the EU AI Act, and PCI DSS, the Payment Card Data Security Standard. One finding surfaces as, say, an ISO secure development gap, with a posture, needs attention, not evidenced or clean. And it is honest about its limits. It maps findings to controls and generates evidence toward them. It does not certify compliance. Finally, the piece that ties it together and makes it provable, the sign snapshot. The snapshot links the static scan to runtime, the exact scan, the rules version, a digest of the findings, the hash of the applied policy. It is wrapped in an in toto DSSE envelope, a CNCF supply chain standard, so anyone can verify, offline, that this snapshot of this exact commit is authentic. Change one byte and verification fails. Trustable holds the signed index. You keep the raw traces and prompts. One scan, compiled into every format your stack and your auditors already speak. Thanks for watching. Trustable works with the standards your stack already trusts. Visit our website for more information.